Okay, using the cheat graph again, I'm going to show you guys how to do the hardest type of sine and cosine function. The hardest type of sine and cosine function is when you have a period change and a phase shift. Now this one is already set up for you. Sometimes it's not set up for you. Sometimes it would look like this. 1/4 x, or maybe the x might be on top of the 4, plus pi over 4, or 1/4 pi. Now that looks kind of hideous. Like, you see this nasty thing right here? If this ever happens, you have to factor out the 1/4 so that it looks like this. Okay? It's very nasty looking. It's kind of tricky. The horizontal shift, or the phase shift, is not minus pi over 4. It is minus pi, which is tricky. So if ever you get something like this, you got to factor out the 1/4. And so when you factor out this 1/4, you would divide right here, and you would divide this by 1/4, or you would multiply this by 4. You know, when you divide by a fraction, you can multiply by the reciprocal. Okay, so now we have this right here. Okay, so let's find our period first. So to find our period, we're going to take that 2 pi and we're going to divide it by 1/4. That is the same as going 2 pi times 4/1. Now we don't really need that over 1, but I'm going to leave it there. And we have 8 pi divided by 1, but I'm going to leave it just like that. So our period is 8 pi. Now, in order to write our period down here, we're going to scale our cheat graph out right here. We need to know the phase shift. This one does have a phase shift. The phase shift is the same as the horizontal shift. So we see a plus pi right here inside the parentheses. When you guys see a plus pi, what kind of shift are you thinking about? Tell your neighbors. Go. Question is, are you thinking up, down, left, or right? And you should be thinking left or right, and more specifically, you should be thinking left. So you could put minus pi right here because we're going left. Or you can say left pi. Both of those answers are the same to me. Now, if we're going left pi, then that means we're not going to start at 0. What are we going to start at? Negative pi. We have to go back 1. Now, what is our period? Our period is 8. So if I go negative pi plus 8, what would this number be? 7 pi. Negative 1 plus 8? 7. Okay, let's find these other ones in here. Now, the trick I like to do, you don't have to do it this way. I like to take this 8 pi, and I like to divide it by 4. Why 4? Because we have 4 sections. 1, 2, 3, 4. So I'm dividing 8, which is the distance from here to here, by 4. And what do I get? I get 2 pi. So that means I just have to add 2 pi every time I go from here to here. Alright, so let's do that. What is negative 1 pi plus 2 pi? That is 1 pi. So I'm going to put a pi right there. That's 1 pi. What is 1 pi plus 2 pi? 3 pi. What is 3 pi? What is 3 pi plus 2 pi? 5 pi. And 5 pi plus 2 pi is 7 pi, so we're in the clear. So we've labeled all our stuff. And because we know that our sine function does something like this, we need a midline, a max, a midline, a min, and a midline. And we're going to put all of those on these lines right here. So, you better bring my cookies tomorrow then. We have our first point right there at negative pi. Oh, snap, I almost forgot. Do we have a vertical shift?
No.
No, so that means this midline is at 0. It is. We don't have to change it. Now, what is our amplitude? It is 1/2. It's positive 1/2. So that means because our amplitude is positive 1/2, we don't have to switch our max and our min. If it was negative, then we would go down to a minimum first and then maximum after that. Okay, so I'm going to say that this is 1 right here, so I can put 1/2 right here. And I'm allowed to do that because this is a cheat graph. I can do whatever I want with my scale. This would be -1/2 right here, and this would be -1. That would be -1 1/2. We don't have to do all that, but I guess I'm just being thorough. And there you have it. So we have our first point, our midline point, and our next one should be our max. What's our max going up to? 1/2. And then we have our midline point again, and then we're going to go down to our minimum, and then we're going to go back to our midline. Beautiful. Now, how do we make this go onto the scaled graph? All right, we want these points on our scaled graph. So, do we have a negative pi on our scaled graph? Nope. Do we have a pi on our scaled graph? Yes, we do. Pi goes up to what? So I'm going to put a dot right here. Do we have a 3 pi on our scaled graph? No. Okay, so this kind of stinks. You guys aren't going to like this very much. But this is a maximum, yeah? Now you see how 0 is right in the middle of this negative pi and pi? But it looks like that's almost halfway between the x-axis and the 1/2. So this is what your line is going to look like. And it stinks because this window kind of stinks. That's your line.
That's it?
That's it. Because this line right here is a different window than over here. What we're seeing is this section from 0 over to 2 pi, which would be right there. This is all we're seeing in this window. We're only seeing this part. Does that make sense? Kind of weird, kind of different. Okay, let's finish filling out our chart. What is our y-intercept? I'm going to say no, because I don't want to do that. It's hard. What you would do is you'd have to plug in 0 to here and figure it out, but I'm just going to say no, because I can't tell from my graph. My x-intercepts, I don't have any on this graph. I'm going to say none. My maximums, those are kind of clear. My maximum is at 1/2, and -1/2 is my minimum. To do the general points for our maximum, we would have to say, we're going to start at pi, and then we would add to that, what is our period? Our period is not 7 pi, it's 8 pi. It's 8 pi, and then we have to multiply it by n, and then put 1/2 right here.
Do we need this?
Then for our minimum point, our first minimum point is at 5 pi, so I'm going to throw 5 pi on here. And then we add a bunch of periods, or 1 period, or no period, to find the other minimum values. The other minimum, the minimum points.